Hey everyone, this is section 1.4 day 1 from key concept 1. Okay, so this is on forms of quadratics. So this is the very first day of notes. Okay, so first we need to define what a quadratic is. Okay, quadratic equation are equations with one or more variables where the highest degree is 2. Now a degree is just an exponent. Okay, so your highest exponent in that equation is going to be 2. So you're going to have x squared in your equations. Okay, another thing is that it makes a U shape, which is called a parabola. Okay, so it's either going to go up or down when you see a graph. Okay, so there are a few key components that you can tell on a graph. So in order for you to identify those, first we need to go ahead and draw a graph. So that's what we're going to do. This is just a sketch. It doesn't have to be perfect. But here is my U-shaped parabola. Okay, so you will notice that it intersects at certain points. Okay, remember that your horizontal axis, the one that's going side to side, is your x-axis, and the one that's going up or down is your y-axis. So we are going to start right here at the bottom of the graph, where it starts curving. This is called the vertex. Okay, the vertex is either going to be a minimum or a maximum depending on your graph. Okay, if it's going up, then you're going to have a minimum. If it's going down, you're going to have a maximum. So if it looks like a U, it's going to be minimum. If it looks like an upside down U, it's going to be a maximum. Okay, that's the first point. Second points are right here where it crosses your x-axis. Now these are called x-intercepts. So you have 2 in this particular graph. It's not always going to be 2, but most of the time it is. X-intercepts, again, is where your graph or your parabola crosses your x-axis. Those are x-intercepts. Okay. Conversely, you will see that this graph also crosses your y-axis right here. So if your graph crosses the x-axis and it's called the y, or the x-intercepts, then if it crosses the y-axis, it's going to be called your y-intercept. Okay, and this is when your graph crosses your y-axis. Okay, and there is one more important point that I need to show you guys on here, and that is through the vertex. There is an invisible line right through the vertex. It goes on forever and ever, and this line is called the axis of symmetry. Okay, if you think of the word symmetry, it means like a mirror image. Okay, it has to be identical from one side to the other. Like if I draw a line in the middle of our face or my face, it will be symmetrical on the left side, on the right side. Okay, that is the axis of symmetry. It literally is a line that cuts your graph in half. Okay, now moving on to the direction of the graph. That is called the concavity. Okay, concavity, the definition of that is literally what direction is the graph going. Now you have 2 possibilities here, which I kind of drew for the minimum and the maximum right above. Okay, it's either going to look like a U, so it's going to go up, and we say that is concave up because it's going up, when A is positive. And I will give you examples of what that means, okay? It's actually, there's an example right under that. If I have f of x is equal to ax squared plus, whatever after, this a is a positive number. If it is positive, then my graph is going up. Okay, on the other hand, the opposite of that is if my graph is going down. So if it's an upside down U, which might happen, that means it's concave down. Okay, so your graph is going to look like that. And that happens when A is negative. Okay, so that A term in the beginning of every equation is going to tell you whether or not your graph goes up or down. Now, that's just by observation. You're not doing any math there. You're just looking at the equation. Okay, now, there are also 3 different types of solutions when we are dealing with quadratics. Okay, the first one is where your graph might look like this, where it barely touches your x-axis. That means that you have one x-intercept and you have one solution here. Okay, another option, something like this. Again, you're looking at your x-axis and it passes that x-axis. You have 2 x-intercepts here, crosses twice, so that is 2 solutions. Okay, and this is the same thing when it is a backward U. And then finally, you might have something like this, where it doesn't cross the x-axis at all. So this is no solutions. Okay, so I'm going to go ahead and give you an example. I'm going to give you key features of a parabola, and I want you, or we are going to go ahead and sketch the graph. Now, what I mean by sketch doesn't mean that it's going to be perfect, okay? If I give you graph paper, or if I give you a graph, grid graph on your worksheets, then I expect the graph to be a little more than a sketch, okay? On your notes, in your notebook, of course, it's not going to be exactly that, but something close to it where you get kind of the picture of what it's going to look like, okay? And all of these quadratics will always look like U's, either a U or an upside down U. So if your graph does not, you are doing something wrong, okay? So make sure you double check that. All right, so the first example, it says sketch the graph of a quadratic function with the vertex at 3, -2, x-intercepts at 1, 0, and 5, 0, and y-intercepts at 0, 2. So I'm going to go ahead and stop at the very top. I'm going to try and graph 3, -2. Okay, 3, -2, if I start from my origin at 0, 0, I go to the right and down. So I'm going to go ahead and go right 3, and I'm going to put a 3 here. And I'm going to go down 2. So that's a -2. So where those meet, I'm going to plot a point. That is my vertex. Okay, so I go ahead and I plotted the first point. Now the second and third point are going to be my x-intercepts at 1, 0, and 5, 0. Remember, this is your x and y coordinate, and these are 2. These are all your x and y coordinates. Okay, so at 1, 0, that's right before the 3, so I'm going to go ahead and draw a 1 here, and then I'll draw a 5 here. Again, it's not going to be perfect, and that's okay. And then I'm going to plot those points. My x-intercepts will be on the x-axis. Okay, so those should be on that horizontal line. And then finally, my y-intercept, which is going to be on my y-axis, is at 0, 2, which is somewhere here. So I'm going to put a 2 there. And my point right there. Okay, now you can see that those 4 dots will connect and make a U shape. That is what you want. Okay, so I'm going to try to make this look like a U as much as possible. And here is my sketch. I'm done. Okay, again, it does not need to be perfect. This will give you full credit on homework or practice or any quiz or test. Okay, this is a sketch. All right, moving on. Now I'm going to give you a multiple choice example. Okay, you are going to match the graph now to the function, okay, which is a little harder. Okay, so all you have is that you have this background or backwards, parabola, right? An upside down U, and you know that it crosses at -2 and at 3 on your x-axis. That's all you know, that it goes down, crosses at -2, and it crosses at 3. Okay, so the first thing we're going to look at is what direction it's going. It is concave down, right? Because it is going down, which means that your A term is negative. Okay, so I'm going to look at my options. I have 4 options here, A through D. Now my A term is always the first number before that parentheses if I have any. But here, I don't see any numbers. But remember, if they don't write one, it's a 1. So I'm going to go ahead and put in a 1 everywhere I see, like right before the parentheses. So I'm looking at these 8 terms that I'm highlighting right now to figure out what my concavity is. Is it going up or is it going down? So since it's concave down, the A term has to be negative, which means that it cannot be A and it cannot be B, because those both have a positive 1. So my answer is either going to be C or D. Okay, so to figure out which one it is, I need to use those points that they cross next. Okay, so my next one, I am looking at my x-intercepts. So the x-intercepts are at x equal to -2 and x is equal to 3. However, when they write it like this with parentheses, like this, okay, you need to basically move that number to the same side of that x, okay, because on your options you don't have x equal to, you have x minus 2 and x plus 2, and the same thing with the 3's. So to do that, I am going to add 2 to both sides here, right? Because remember, whatever you do to one side, you have to do to the other. So now on the left side, x plus 2 is just x plus 2. And then do the same thing with the 3. I'm going to subtract 3 since it's a positive 3, and I get x minus 3. So this is what I should be looking for in my answer, which means that my only option would be option D. Okay, so that is my answer. Now, we've just discussed a lot of graphing. Now we're going to go into what actual quadratic functions look like. Okay, so they might look different. They're not always the same, and that's because there are different types of quadratic functions. There are actually 3 types of quadratic functions. Okay, the first one being standard form. Okay, standard form looks like this, where you have f of x is equal to ax squared plus bx plus c. Okay, now when you are looking at standard form, it gives you 2 pieces of important information. The first one is the concavity. Okay, and here you look at A. Okay, so you are looking at A, which I'm going to highlight here, to tell you whether or not the graph is going up or down. So that's concavity. And the other piece of information is the y-intercept, and the y-intercept is your C term here. Okay, so the y-intercept is at 0, C, if I write it as a coordinate, or y is equal to C, if I write it as something that it's equal to. I would take either or. Okay, now that's standard form. The next one is vertex form. So vertex form looks like the following equation. F of x is equal to A times x minus h squared plus k. Okay, so if you notice, this also has A in it, just like standard form, and that's because it also tells you about the concavity. Okay, so you also have to look at A for the concavity here. Okay, whether it is going up or down. Remember, concavity just means that your graph is going up or down. That's what concavity is. It's where is it curved to, towards the bottom or towards the top. Now it also gives you the vertex, excuse me, at h comma k. Now this is a coordinate. Okay, the only thing that you have to remember with this coordinate is that at this point, at the h point, when you are writing the coordinate, it is the opposite of whatever that is. Now that doesn't apply to k, it only applies to h because it's inside the parentheses. Okay, so you have to do the opposite. So if, for example, it says x minus 3 in the parentheses, then the h would be a positive 3, because that is the opposite of that. And then finally, the axis of symmetry is at x equal to h. Okay, so you have h, whatever you got on the vertex, that is the exact same h. Okay, so you're just copying that h. And then the final form is factored form. So factor form is f of x equal to a times x minus r1 times x minus r2, where r is a root. It's a 0, a solution. Okay, so again, if you notice, a is in common with standard and vertex form because it is the same thing. You look at a for concavity. Is it going up or is it going down? Is it positive or is it negative? Okay, here, so it gives you the concavity and it also gives you the x-intercepts. Okay, the x-intercepts you can write as r1, 0 and r2, 0 as coordinate pairs, or you can write it as x equal to r1 and x equal to r2. Okay, it is up to you. Again, because these are in parentheses, excuse me, let me erase this. You are doing the opposite of those numbers, whatever number it gives you. Okay, that's so you have to remember. Now, if I were you, I would get these 3 forms and put them on index cards, okay, so we can practice them in class. Trust me when I tell you that these are so important. You need to know these 3 and you need to know specifically what each of them tells you in order for you to do well. Okay, so practice makes perfect.